many annotated? Are they?
Yeah, so we looked at them in some detail. So DN3 cells, so they have functionality, right? We don't think they are non-functional. The DN3 cells do go into tissues and they secrete antibodies in tissues. I think you should think of tissues and DN3s as precursors of plasmablasts. And that if you reactivate them, they'll become plasmablasts and they make antibodies. And I think that's why they exist.
Very interesting. I'm thinking about a situation where you have ICMR antibodies against a specific individual. When you try to boost, right, so the concept is that these antibodies bind to the individual and then block the activation of B cells. In this kind of scenario, I assume that the memory B cells that are activated, those are, is this still happening in the lymph node or is it outside of the lymph node?
Yeah, so all B cells are recirculating. These are all recirculating cells. You think most of the activation does occur in lymph nodes, the secondary lymphoid organs. So the interference phenomenon where antibody interferes is very well studied for germinal centers. So as you probably know, if you know Ali Bedi's description of germinal centers, early during the COVID pandemic, the germinal centers he saw were there around for about 6 months. 2 years later, the germinal centers were around for like 2 weeks. Because you have so much antibody interference by then, you made so many antibodies, your antigen is not going to have the epitopes available to even drive the germinal center response. So the germinal centers will decline. So I think that is the antibody effect does exist. I think if you now needed antibodies, so why is it that every time we got a boost, in the early days, if we went and got a boost, because the sugar high of antibodies going up? That's probably because of all your extrafluid memory B cells rapidly differentiating to give you plasmablasts and give you antibodies. And then you get the spike of antibody which protects you. But it's only for that much time. So that's where I'm looking at it. I think there's a value to both. And the fact is, one is a memory population and you want it around, especially I think if your virus varies a bit, where the classical memory population may not be that good. It's great against the original virus, but this might be good enough for you.
Any more questions? So thank you, sir.
There's somebody in there.
Sure.
Sir,
I can see it.
sir, I was asking that you use the stock of HA for seeing the durable affected memory B cell response. So, is the epitope against which against which you are targeting, does it play a role in how strong or how durable the affected memory B cell response is?
So I should tell you, unlike Rama over here, I know nothing about all these pathogens. Okay? So when we were seeing this response, I chatted with Dan Lingwood, this is my neighbor, and I said, this would be nice to use something that's suboptimal so that we can now see what is the value of having response be generated. And the stem, the way it works is that the head is very immunogenic. The stem is not that immunogenic. People are focused on the stem because of conservation across viruses, right, across strains. So you want to use a stem in a vaccine if it really works. You don't have to make a new vaccine every year. And that's why they made these stabilized stem nanoparticles. And when you use that vaccine in mouse experiments, you do not get 100% protection because your VDJ combination gives you B cells which don't seem very well to begin with. So your precursor frequencies are neither high or good enough affinity. So your responses are always nothing like the head responses. That's the reality. For us, what turned out, we didn't think it would be so clear-cut for us, is that if you survived, then you were a mouse that made a good amount of extracurricular memory population. If you didn't survive, you just had failed to make those memory cells, just because even if I'm genetically identical, in the mice strain are genetically identical mice, class 2 is the same, everything else is the same, VDG recombination is random. And you might just start off with a different precursor frequency of not so great B cells, and that shows up in some mice are great, they're just lucky, and some mice are not. That's the way we see it. But we're testing this. You can tell me, what should I have done to test this further? We're actually doing it, right? We're actually transferring memory cells into mice which have no B cells and asking the same question.
Sir, I have a quick question. So if in the context of a viral infection, have you checked how much time it takes for this extrafollicular response to happen?
2-3 days.
And like with your experience, like is it more effective in the case of a persistent viral infection or in an acute infection?
So I mean, it's not like, is it more effective or not? Persistent viral infection just means we didn't do a good job, right? We couldn't clear it. That's a different story altogether. So I think in a persistent viral infection, the immune system is fairly stupid. It doesn't know what's going on, right? You have a persistent viral infection, you keep making more extrafollicular memory cells, you keep trying to make more germ centers, but you probably won't be able to do it enough because of interference from antibodies. So you will just accumulate a lot of what people will call either short-lived cells, like what I call transition, or memory cells. And you'll see that, but it's not doing you much good in those circumstances.
Okay, in that case, so in case of infections that never comes to the blood, like in case of rabies and other infections that take a neuronal route, do you think that this kind of responses can be elicited at that time also?
I'm sure in any situation where an antigen goes to a lymph node, you will elicit this kind of a response. Clearly in rabies, it hasn't turned out to be much use to you, for other reasons.
Okay, thank you.
So,